Hello everyone. In the previous session we have stopped at second method of indirect method to measure the horizontal distance between 2 points on a sloped ground. Now we will study the third method, that is hypotenusal allowance, to calculate the horizontal distance between 2 points which are located on a sloped ground. See here, I have point A and point B which are located on a sloped ground. Okay, so whenever I stretch a chain, okay, if I stretch a chain on the sloped ground to measure the horizontal distance between point A and B, okay, if I stretch the tape from point B to C, if I stretch the tape from point B to C horizontally, okay, it will end at point A dash. It will form an arc and it will end at point A dash, correct? But the actual horizontal distance will be B to C. That will give you the actual horizontal distance. Here, if I stretch the tape on inclined ground, it will end at B to A, correct? But actually it has to end at A dash, but it will end at A. So this correction A dash is called as hypotenusal allowance. See here, hypotenusal allowance. Read it here. In this method, a correction is applied in the field at every chain length. At every chain length, I will go on stretching the chain, and at every chain length, I will go on adding the correction, because since the ground is sloped, the measured distance will be more than the horizontal distance. So you have to apply the correction at every chain length, correct? This facilitates in locating or surveying the intermediate points. When the chain is stretched on the slope, the arrow is not put at the end of the chain, but it is placed in advance of the end by an amount which allows the slope correction, right? See here whenever I stretch the tape from B to A, once the chain finishes, I cannot put the arrow there. I have to put the arrow at A dash. I cannot put it at A. I have to put it at A dash, because the ground is sloped, the measured distance will be more. So the correction I should apply, and I should put the arrow in advance to the point A, that is at A dash, right? So how much in advance I should put the arrow? That is A dash. A dash, that is your hypotenusal allowance. How to calculate that A dash, we will see it here. So in figure 3.27, this is your 3.27. BA dash is one chain length. BA dash is one chain length. On a slope, the arrow is not put at A dash, but it is put at A. The distance A dash being such magnitude that horizontal equivalent of BA is equal to one chain. The distance A dash is sometimes called as hypotenusal allowance. Okay. So considering this triangle, so one chain I will consider it as equal to 100 links. One chain I will consider it as 100 links. You can say BA dash is 100 links, whereas BA is 100 sec theta links. Links you have to mention it, because sec theta is BA by BC, correct? Sec theta is BA by BC. BC is what? One chain. One chain is what? 100 links. So that is why we have written it here. BA is equal to 100 sec theta links. Now, hence A dash is equal to A dash. A dash is what? Total BA. Out of total BA, I have to deduct BA dash. So BA, I have the equation 100 sec theta links. BA dash, I have 100 links. A dash will be is equal to BA minus BA dash. So that is 100 sec theta minus 100 links. That will give you the hypotenusal allowance A dash. The correction which I should apply, A dash is 100 into the bracket sec theta minus 1 links. 100 into the bracket sec theta minus 1 links. So now sec theta is equal to 1 plus theta square by 2 5 theta raised to 4 by 24. So they have written it in mathematical format for the sec theta, so you ignore that. Consider only sec theta is equal a dash is equal to 100 1 plus theta square by 2 minus 1 links. 1 plus theta square by 2 minus 1 links totally. So if I simplify this a dash is equal to 50 theta square links, correct. So now 50 theta square links, if theta is provided in radians or theta is provided in degrees, so the value changes here, correct. So now come here, next a dash is equal to 50 theta square. Whenever it is given in radians and whenever it is given in degrees, that will change. Okay, they have given it here. If the slope is measured by leveling, it is generally expressed in 1 in n, meaning thereby 1 unit vertical and n units horizontal. So since it is a sloped ground, vertical to horizontal ratio we have to mention, correct. So theta will be 1 by n radians. So a dash will be 50 theta square is equal to 50 by n square. So a dash will be 50 by 10 square. If slope is 1 in 10, 50 by 10 square will give you 0.5 links. 0.5 links means 100 link is one chain, 0.5 link is how much, that we should calculate there. Okay, so here the one example is also they have given. The distance between the points measured along a slope is 428 meters. Along a slope is 428 meters. Find the horizontal distance between them. If the angle of slope between the point is 8 degrees, the difference in level is 62 meters. The slope is 1 in 4. So we have to use all the indirect methods to calculate this. First one, they have given the slope distance, that is 428 meters. That is L, the slope distance they have given. D is horizontal distance. So in first case they have given you the angle. So horizontal distance will be this. Whenever they give you the angle, the horizontal distance will be this. D is equal to L cos theta, the first one. See here, L1 cos theta 1 is there, right? So D is equal to L cos theta. In first case, the distance we have got it as 423.82 meters. So in the second case, what they have given, they have mentioned you the difference in elevation is 62 meters. So you have to use second method, second indirect method. D is equal to L square minus H square. 428 square minus 62 square. Next they have given you slope is 1 in 4. So we have to use, whenever they provide the slope, we have to use hypotenuse allowance equation, correct. So 1 in 4 means tan theta is equal to 1 by 4, 0.25 we will get. Theta will be 14 degree 2 minutes. So L will be L cos theta, 415.23 meters. So same case again we have two problems here. So these I will give you assignment and I will share the notes on the link. You can solve it, and if you have any doubt you can contact me. Okay, thank you.